Alright, everyone, welcome to Medical Tutor. Today we are going to be talking about the changes of matter. Now, before we do that, I want you to click the subscribe button and put on the notification bell for more notifications on our next releases on matter in general. So, I would appreciate if you could kindly go back and watch the previous video on introduction to matter if you haven't done so. And I'm going to embed the link in this video for those of us who still wants to do a little revision on the video. So thanks for doing that. Okay, let's start our topic for today, changes of matter. In our previous video, we did the definition of matter. We also talked about the transitional stages of matter. We talked about the three states of matter, the gas, the liquid, and the solid. I believe we all remember that. Okay, we also talked about the phase and the boundaries we also talked about the molecular attraction. We talked about the molecular arrangement of substances in different states of matter, and we used water as an example. Okay, in this video we're going to be talking about changes of matter. Changes of matter. Now, talking about changes of matter, we have two different types. We have the physical and we have the chemical. So we have two changes of matter, the physical change and the chemical change, and we are going to pick this one by one. Now, the physical change, the word physical itself means the way it appears. Physical means the way it looks to you. Okay, what is the physical appearance of the ball? It is yellow, it is red, it has stripes, it has this and that. What is the physical appearance of the clothes you are wearing? It is blue in color, it is a round neck. Now, physical means things that are mostly visible to the eyes, things that you can feel, things that you can like feel or see or touch. These are things that are oblivious to our senses in particular. Now, physical change means a change that deals with differences in the physical properties of a matter. A change that deals with the physical properties of a matter. For example, the physical property of water, we can talk about the color, we can talk about the weight, we can talk about the appearance in terms of turbidity. We can talk about the state of matter, whether it is solid, liquid, or gaseous. Now, these are all physical changes of matter, and we will talk about the properties of these changes one by one. But before we do that, let us mention other examples of physical changes. We can talk about the condensation. If you were here in the last video, we did changes of states of matter. We have condensation, we have freezing. Freezing is also a physical change. We have melting. Melt is also another physical change. We have sublimation, which is also part. Okay, keep listening them. We have evaporation or vaporization and etc. Now, the reason why all these are called physical changes is this. Now, look at condensation. Let's assume we condense our gas to liquid. Can't we evaporate our liquid back to gas? Can't we evaporate our liquid back to gas? Okay, let's assume we have something like, we have ice water. Ice water is solid in state, right? And then I converted my ice water through melting into ordinary water. That's liquid state this time around. This one is solid, and we use what they call melting to convert it into ordinary water. Now, can't I convert this water back into ice water by freezing again? Of course, I can. So any process or any change that can be easily changed, easily reversible, is known as a physical change. As you can see, all I just have to do is put it in the freezer and it's back again to the normal ice water state. So any change that is easily reversible is known as the physical change. And another important characteristics of physical change is this. Physical change does not lead to the production of any new matter. Physical change does not lead to the production of any new matter. H2O gaseous state, that's steam. If I condense it, it will give me H2O liquid state, right? If I freeze it, it's going to give me H2O solid state. Now, as you can see, is there any change here? There's still H2O, H2O, H2O. They are all still giving me the same matter, which is water, water, water. although they are in different states. One is in gas, one is in liquid state, one is in solid state, but they are all still the same: water, water, and water. So in physical change, the only thing that changes might be the state, but the properties of those substances itself does not change. I'll repeat this again. In physical change, the state of matter can change. However, the properties of those substances will remain the same. So we've mentioned two characteristics of physical change. The first one, we said the processes are easily reversible. I can easily melt my water and I can easily freeze it back. And the second characteristic is that most of the times it's only the state of matter that changes. There's no new product formed, and that's the physical change. Okay, another characteristic of this is it involves no change in mass. Okay, you see, the same mass of pure water that you bought, let's assume the mass of pure water you bought is, your pure water is 50 kg. By the time you put this pure water, which is in liquid state, inside fridge, you are going to be having ice water, right? Now this ice water will still be giving you the same thing, 50 kg. The reason is because normally pure water contains molecules that are not closely related to each other, although they are close but not really closely related. Now let's draw this in a full sheet again, and look at this container here. We have O. These are water molecules. This is your pure water. Now this is ice. Ice is like this. Now we are not adding new molecule to water because it is converting from liquid to ice. No, we are not adding any molecule. The only thing that is happening is that the distances between the molecules in the first place has been removed. So all these molecules are converging. They are now getting closely related to each other in order to become ice. So initially, if this was 50 kg, we are still going to be having this other one as 50 kg as well, because nothing really changed. We didn't remove a molecule, neither did we add any molecule. So in physical change, there is no mass change. In the initial state, it is 50. In the final state, it's also going to be 50. The same thing, another example that is very popular is our candle wax. This is your candle. Once you light the wick on and you put it on fire, by the time everything burns finish, you're going to see a remnant of candle on the floor, right? Now, if you weigh that same remnant, everything together, is going to be giving you almost approximately the same mass that you have here. If this was 10 kg, you're going to be having almost 9.9 or even 10 kg in some cases, if loss is not incurred by carelessness or any other thing. So which means before and after a reaction, for a physical change, the mass is always the same thing. For a physical change, the mass is always the same thing. There is no mass change. And there's another important thing, or important characteristics of physical change we have to know. It requires little energy. It requires little energy. Or if you want to evaporate your water, all you just have to do is place it under the sun. Just put your water inside a container and put it under the sun, and it's going to evaporate, turn into gas, and go away. That's all. If you want to freeze it, just put it inside the freezer. Temperature is reduced and the water freezes. They are there together again. That's all you have to do. It requires little or no energy. In some cases, you might not even require any energy. Now, in cases of candle, for example, something like this, in cases of candle, the energy that is going to be applied there is heat energy, because once you light on the wick, the fire is going to keep burning, and it is the heat that is going to keep melting the wax. Eventually, when the heat is removed, what happens to the wax? It solidifies again. So in physical change, one, it is easily reversible. Physical change, it is easily reversible. And second is that there's no new product. No new product. Third is that there is no mass loss. The mass initially is also the mass final. And it requires little energy. So all right, that's all about the physical change. Let's check the properties of a chemical change. We said the physical change means alteration of the physical properties of matter. It involves things that you can easily see, things that you can easily feel or touch. That is physical change. However, that does not apply to chemical change. Now, in chemical change, there are a lot of things that differentiate it from physical change. One, the change does not involve the physical properties of the matter. The change involves the chemical properties of the matter. I repeat, in physical change, the change involves only the physical properties, right? But in chemical change, it involves the chemical properties. It's very easy to know. Physical involves physical, chemical involves chemical. So then, let's move on to the characteristics of chemical change. The first characteristics of chemical change is just the opposite of physical change, and that is, it is not easily reversible. Not easily reversible. Okay, let's give an example of a reaction like this. Okay, this is a paper. If you burn paper, if you want to burn anything, you need to use O2, right? Combustion. It is necessary for every combustion. So if you burn a paper, this is your paper, maybe your notebook. What is it going to give? It's going to give you ash, right? Ash plus some heat loss into the environment, maybe a flame as well, right? So if you burn your paper, it's going to give you these three things or more. Now, can you combine all these things and form your paper again? Can you combine all these things and form your paper again? No. You can't burn your paper and then combine them again in order to give you anything. No, it's not going to work. Do we understand? So, for physical change, we can do anything we want to do in physical change and still reverse. But in chemical change, once you do it, it's very difficult for you to reverse. In some cases, it is always impossible. Like this, if you want to burn wood, okay, what about burning wood? Most of us must have done this before. If you burn wood, it's going to give you ash, some energy, charcoal, and etc. Now, can you combine any one of these back into the wood? No, it's impossible. So in chemical change, it is not easily reversible. Once it is done, in some cases it is completely done and it can't be changed again. Okay, we also have another property. It leads to the production of new matter. Remember, in physical change, water in gaseous state is still water in liquid state and it's still water in chemical state, in solid state. But in chemical change, water is never water. There will always be a kind of change to it. Now, let me give you an example. An example of this is rusting of iron. Rusting of iron. Now, in rusting of iron, there is oxidation of the metal surface. Now, when there's oxidation, the constituents that make up the metallic surface in the first place are going to receive a massive change in every form. They are going to receive a massive change in every form. They are not going to be the same thing again. So you see, what you have here is obviously different from what you have here, and it's obviously different from what you have here. So you're not going to be having the same thing again, just like it is in physical change. You're going to be having an entirely different product. Another example of this is, okay, if you burn your, okay, like I said burn the paper. If you burn your paper, it's going to be giving you ashes, right? Ashes on its own is a new matter. It's going to give you flame, etc. But the most important product of burning your paper is ashes. Now, ashes its own is an entirely new matter. It's not the same thing as paper. Anything can give you ash. Anything can give you ash. Burning bodies can give you ash as well. However, this ash is a different matter from paper on its own. So as you can see, we have paper here, but we have ash here. Do you understand? So in chemical change, we have different things entirely. We don't have the same thing at all. We have new products. So whenever a chemical change is being carried out, we expect a new product to be given out. And that's why it's called chemical change, because it involves the chemical properties of that matter itself. Okay, another example is this. By bleaching as human, by bleaching, you're only changing your physical appearance. But bleaching your physical appearance cannot change your attitude. That's an example of physical change. Do we understand? Bleaching your physical appearance cannot change your attitude. Understand? But if you change your attitude, everything about you is going to change. You can bleach and become fair today, but that does not change who you work with. That does not change how you work. That does not change what you wear. Everything you still do will still be the same thing. You are still going to be you. You were tardy yesterday, you are still going to be tardy today. You were hot-tempered yesterday, you are still going to be hot-tempered today. However, in chemical change, what changes is not the physical appearance. It is the inner self. For example, your attitude, your personality. Once your personality changes, whatever you wear is going to change. When personality change, what you wear, what you eat, who you talk to, what you say, wherever you go, places you visit, everything is going to change. It's going to receive a massive change. So that's to state the difference between physical and chemical. The physical deals with the physical properties. The chemical deals with the chemical and inner properties. And that's why the chemical change will always give a new product, whereas the physical will never give a new product. Okay, I think we understand that. Let's move on to the third change. It involves mass change, not a mass loss in some cases, or mass gain. Remember I told you in physical properties and in physical change that there's no mass loss and there's no mass change. It's always the same thing, 50-50 kg. However, that does not work for us here in chemical change. In chemical change, there are a lot of varieties. For example, when you burn paper, it is going to be lost, ash is formed, flame is formed. Now a lot of this mass is converted into different forms, which will be lost into the environment. And in some cases, you might also gain. So whichever one it is, in chemical change, mass change is positive. There's always difference in mass. If you started with 20 kg before, you might not necessarily be having 20 kg at the end of the reaction. There must be something that will be different. So that's about chemical change. And the last one is that chemical change requires energy, a considerable amount of energy. It does not just happen on its own. No. For example, let's assume we're having something like neutralization, HCl plus NaOH. This is an example of a chemical change. We are going to be having what? H2O plus NaCl, right? Now, this is changing to this. You can see HCl, NaOH. These are the initial substances, right? Now, when you get here, what do you say? H2O. Is H2O the same thing as HCl? No. There are two different substances. That's to prove that in chemical change, new product is formed. And you can say NaCl is here. This is another new product. That is salt and water. So now you notice that before anything like this can happen, we require an amount of energy to stabilize the reaction. If there is no energy stabilizing the reaction, then it's going to go awry. A lot of things are going to happen, and that is for chemical pathways, for higher level chemistry, which is not for this video. However, for this reaction, a considerable amount of energy had been used. And in chemistry, we have two types of energy transmission. We have the exothermic, which is for temperature, losing temperature. Endothermic means gaining temperature. We also have the exogonic, and we have the endogonic too. However, these are all for future topics. However, you just have to know that in chemical change, there's always a considerable amount of energy involved, and that differentiates is for physical change. Okay, let's do a quick recap of what we have done. In the beginning, we said physical change is reversible. We said it leads to no new product at all. It's just the same thing, and no mass change. We also have, it requires just little energy, whereas in chemical changes, they are not easily reversible, and in some cases not reversible at all. And there's always a new product, and there's mass change. And for the last one, it requires a considerable amount of energy. So that's all about this tutorial. Would appreciate your comments in the comment section for any question you have for us. So in the next tutorial, we're going to be talking about our properties of matter. That includes the elements, compounds, and mixtures separately. We're also going to be talking about the delinquency of compounds entirely. So ensure you put on your notification bell for our incoming releases. Thanks for watching. God bless.